Hi guys, I hope you're doing well. Welcome to the MechPerman channel. Today we're going to design a dual motor mixer that has a really cool design. Let's see how we're going to make it. Let's see what we can do. In the first step, we're going to model the base. We have some relatively complex surfaces here, but I'm sure we can design them successfully. Now I'm going to roll back the design history step by step and explain the design process to you. First, we have the base here. We created a sketch and then we extruded that sketch. I'm going to explain it very quickly. We applied fillets. Then we used the shell command to hollow out the base. After that, we created a plane up here so that we could use the boundary command to create a loft like this using this upper sketch, the base sketch that we created down here. And a series of guide curves that define the path of the loft and show us how this loft should go upward. Finally, by using the trim surface command, we trimmed the surface and created a suitable curvature so that the moving part of the mixer could move on it. At the end, we assigned a thickness to it, which you can see here. Then we applied a fillet around the entire base. Here, we created the location of the pin that connects to the moving part. At the bottom, to hollow it out and create an opening through it, we made a cut here. Previously, the bottom was completely closed, and with this command we opened it. Here, we created the location where the bowl sits, removed the material from that area, and applied a fillet around it. Finally, we had a protrusion here, and by using this command we removed that protrusion. Now let's move on to the second step, which is designing the moving part. There are a few complexities there, but I'll explain everything to you in complete detail. I'm sure you'll be able to do it. As you can see, I'm opening the moving part. Let's come here and roll back the features. I first used a revolve feature. I started by drawing a semi-cylindrical sketch here, something like a capsule, and then I revolved it. After that, I created the connection points for the mixer beaters. Then I flattened the top surface and gave it an ergonomic shape that also adds to its appearance. I also flattened this area here. Here, I created an offset surface. What is this offset surface for? I'll explain that a little later. For now, I'm going to hide it so it doesn't get in our way. Maybe I created it a little earlier than necessary, but that's okay. Let's move on to the next step, and I'll explain it there. Here I created a loft. I drew one base sketch here and another upper profile here at the location where it connects to the moving pins. I added a chamfer around this area to improve the appearance, and I also added fillets around the connection points of the mixer beaters, again just to improve the appearance. Here is the location for the control knob along with its fillet. Then I used the shell feature to hollow out the inside of this housing so that it would be ready for plastic injection molding. In other words, the main body of our part is now prepared for plastic injection molding. Of course, to design the injection mold, we still have several more steps to go through. If I get the chance and you're interested, be sure to let me know in the comments so I can also prepare the plastic injection mold design for this mixer. That depends on how much you support this project. If I see your comments, I'll definitely make that video. And don't forget to like and subscribe so I can share this video with even more people. Now let's continue. Here we created the connection points for the mixer beaters. Then I used a cut feature to make this area more ergonomic. As you can see, let me explain it very quickly. We created the pinholes. Now we've reached a stage where the work may become a little more complicated. As you can see, I created an offset surface from this section because I wanted to create the clearance for the movement of the base against this moving part. If this moving section remained completely closed here, the upper part wouldn't be able to move. So I had to cut this area. To make that cut, I used several surfaces, as you can see here. I created this surface first. Let me show it to you. This is the surface. Then I extended it. In the first step, I created a 2 mm offset surface from this surface, so this new surface was created at a distance of 2 mm. After that, I used extend surface to extend it beyond the required boundary. I did exactly the same thing on the opposite side, as you can see, and extended that surface as well so I could separate this region using the split feature. If we open the split feature, you can see these surfaces. This surface, this surface, this surface, and this first surface that I mentioned earlier. Let me show this one as well. I created this surface so that I could separate the lower section and prevent the cut from extending all the way through. In other words, I defined a boundary and told SolidWorks to remove the solid material only inside that boundary. Then we confirm the feature. As you can see, I removed the purple-colored region from the feature. If I click here, you can see the entire body again. The split feature gives an error because no region has been selected yet. Then I simply select this region and tell SolidWorks to remove it. One of the great advantages of the split feature is that you have complete freedom to choose which regions should remain and which regions should be removed. So, I selected the purple-colored region and removed it. As a result, that section was removed. Then, in the next step, I created the location for the on-OFF switch. Finally, I created a cut for the on-OFF lettering. Here, I created a pattern for the holder of the mixer beaters, the control knob, and the display area for the knob. Then, I inserted my own Mecperman brand logo. I did this by using the insert part command. After you insert that part, if you have the locate part option enabled, the mate tools for positioning that part become available. In other words, you can access the mate environment and tell SolidWorks which bodies should be moved. Here, I selected all the bodies that I wanted to move. Then, using the options below, I told SolidWorks, for example, to position this face 35 mm away from this face, or to mate this upper face with this face. In other words, it's a kind of mating inside the part environment. Normally, this is very easy to do in the assembly environment, but in the part environment, as I mentioned before, the workflow is a little different. Then we confirm it. After that, I added a few chamfers to improve the appearance. Here, I created the hole for connecting the mixer beater, the screw holes, and finally another chamfer here. This completes the overall shape of the control knob. Finally, I hide the construction surfaces that we no longer need so they don't get in the way. This is how we finished designing the upper section. Now let's move on to rendering and animating the product. Let's see how we can do that. In this step, I'm going to show you how to animate this dual motor mixer model and create a realistic rendered animation. If you ever want to present your projects, a rendered video can make a huge difference in the quality of your presentation. First, we enter the motion study environment. As you can see, I have already created several keyframes to animate the movement of this mixer. Here you can see how the mixer moves. What I did first was enable auto key. I turned on the animation auto key. Then, for example, I moved the mixer from its open position into the bowl. I also made sure that the orientation option was enabled and not disabled. Why is this important? Because when orientation is enabled, camera movements are also recorded. As you can see, the camera is rotating here. When this option is enabled, every movement you make is automatically recorded. For example, if I move to the 9th second and rotate the camera, you can see that another keyframe is automatically added. After recalculating the animation, you can see that the camera rotation has also been added. It's actually very simple. While the camera is rotating, you can even animate other components. For example, I can open this cover during the camera movement. As you can see, because auto key is enabled, SolidWorks automatically creates another keyframe. Then I can continue the animation. For example, at the 11th second, I can fully open the cover, add another camera movement, and recalculate the animation again. As you can see, those movements are also added. It's really easy, and you can create these animations very quickly. After you've finished creating your animation, we move to the rendering stage. How do we do that? Go to SolidWorks Add-ins and enable SolidWorks Visualize. I'm using SolidWorks 2026, and Visualize is already installed with this version. If you're using an older version of SolidWorks, you'll need to install SolidWorks Visualize separately. Once I enable it, a new Render Tools tab appears here. From there, I can export the model to SolidWorks Visualize, including all of the animation data. Now you can see that the animation option is also enabled here. I confirm it, and the animation section becomes active. Now I'll adjust these materials again. For example, I'll change this one to metallic black. In the color reflection section, I'll increase the reflection. Then I'll adjust the roughness value so the surface becomes a little shinier. Next, I'll create some reflections in the environment. As you can see, the reflections create a nice shadow effect like this. I don't enable the environment rotation option because if I do that, the rotating environment changes the shadows during the animation. Now everything is ready for rendering. If I press play, you can see the animation that we created in SolidWorks. However, it doesn't include the camera movement yet. Now I'll show you how to add that. First, I'll save this project. Now, in this section, I click Add to New Group. Then I select Create New Camera so that we have a camera available to create camera movements. For example, I go to the second of the timeline and create a small camera rotation. Then I right-click and create a keyframe. Next, I move to about the 8th second and create another camera rotation. As you can see, because Auto Key is enabled, Visualize automatically creates the keyframes for these movements. Then I move to the next point in time and add another camera rotation. Again, I move forward in the timeline and continue adding camera movements. As you can see, while the moving part is operating, we're also creating a full 360-degree camera rotation around the model. We can even zoom in to make the details clearer. Like this. We can continue this until the 11th second. Now, if I press play, why is the animation continuing all the way to the end? Yes, that's because the end point of the animation timeline was set farther ahead. That's why it kept playing until that point. Now, if you look, you can see that our animation is now playing correctly with the camera rotation. Now, the only thing left is that I can have a nice camera movement there. Now that our video is ready, we can either use the render option from the Tools menu or simply click this button here. Then we enable animation and leave all the other settings at their default values. We click Next. For the rendering mode, we can choose Accurate to get the highest quality. Of course, this depends on your graphics card. If your graphics card isn't very powerful, you can use the first or second option to make the rendering process faster. Now, regarding the render passes, these determine how many rendering samples are calculated during the rendering process. To reduce the rendering time, I'm going to lower the number of render passes. Then I click Next. Now we select the location where we want to save the rendered video. Finally, we click Render and wait for the rendering process to finish. Well guys, after about 10 minutes, our render is ready. From here, I can open the rendered file. As you can see, it plays the animation exactly the way we wanted. I hope you enjoyed this tutorial. If you did, please like and subscribe to the channel. If you have any questions, feel free to ask them in the comments. I'd also be happy if you shared this video with your friends, especially those who are interested in mechanical design and work in the field of mechanical engineering. I hope you found it helpful. I wish you all the best, and I'll see you in the next project. Goodbye.